Charles Proteus Steinmetz was a pioneering electrical engineer whose work laid the foundation for modern power systems. He developed essential mathematical tools for analyzing alternating currents and understanding magnetic losses, which are still used in electrical engineering today. Steinmetz's innovations directly influenced the creation of the efficient and reliable power grids we rely on. A famous photograph shows Steinmetz alongside Albert Einstein, highlighting his recognition as one of the foremost scientific minds of his time. Despite having kyphosis, a condition that caused a curvature of his spine, Steinmetz never let his disability define or limit him. Instead, he used his brilliance and determination to overcome societal barriers, becoming a leading figure in electrical engineering and an inspiration for generations. Steinmetz's ability to simplify complex mathematical concepts, like the square root of -1, into practical tools for analyzing electrical systems exemplifies his genius. His contributions continue to influence how we design and optimize power systems today. Through his work, Steinmetz proved that physical challenges are no obstacle to intellectual achievement. Introduction of complex numbers. Steinmetz begins by acknowledging that the square root of negative numbers has already expanded the number system. These numbers, which he calls quadrature numbers, are essentially complex numbers that include the square root of -1. Multiplication and rotation. He explains that multiplying a positive number, which we will call a, by the square root of -1 results in a new quantity, which does not initially have an intuitive meaning. However, repeated multiplication by the square root of -1 reveals a pattern. 1. After one multiplication, the result can be visualized as a 90-degree rotation in the plane of complex numbers. 2. After two multiplications, the result becomes negative a, equivalent to a 180-degree rotation. 3. After three multiplications, it rotates another 90 degrees, completing a total of 270 degrees. 4. After four multiplications, it completes a full 360-degree rotation and returns to the original number a. Higher roots of negative numbers. Steinmetz notes that higher roots of negative numbers, such as the fourth root of -1, represent intermediate rotations in the plane. For example, the fourth root of -1 corresponds to rotations of 45 degrees, 135 degrees, 225 degrees, and 315 degrees. These rotations create four distinct points in the plane, representing the roots. No further extension of the number system. He concludes that while these roots create a pattern of rotations, they do not fundamentally extend the number system beyond what is already represented by complex numbers. Understanding roots of negative numbers. 1. Steinmetz begins by noting that the square root of -4, for example, cannot be -2 because -2 squared gives +4. Similarly, it cannot be +2 either. This leads to the idea that there must be another kind of number to explain this situation. 2. He explains that numbers like the square root of -1 introduce a new way to represent direction. For instance, on a number line, positive numbers extend to the right, negative numbers extend to the left. 3. Multiplying a positive number by -1 reverses its direction, effectively rotating it by 180 degrees. The concept of quadrature numbers. 1. Multiplying by the square root of -1, which Steinmetz refers to as a quadrature number, rotates a number by 90 degrees instead of 180 degrees. 2. Repeated multiplications of a number by the square root of -1 create a pattern. After one multiplication, the number rotates 90 degrees. After two multiplications, it rotates 180 degrees. After three multiplications, it rotates 270 degrees. After four multiplications, it completes a full rotation of 360 degrees and returns to its original position. 3. These numbers are not aligned with the usual left-right directions of positive and negative numbers. Instead, they represent directions up and down, creating a new axis of representation. 4. For convenience, the square root of -1 is commonly written as the letter J, or I in some contexts. Hasher quadrature numbers in applications. 1. Steinmetz explains that quadrature numbers are useful in situations with four possible directions, such as in electrical engineering when dealing with alternating current vectors. Horizontal directions represent ordinary positive and negative numbers. Vertical directions represent quadrature numbers, which are positive upward and negative downward. 2. In problems with only two directions, like time, past, and future, quadrature numbers are not applicable. Similarly, in cases where only positive quantities are meaningful, like illumination or absolute values, negative numbers may also have no practical use. Hash key point. Multiplication by the square root of -1, or j, is a way of changing direction by 90 degrees. This is fundamental to understanding alternating currents and vector mathematics in electrical engineering, where these quadrature numbers represent directions perpendicular to the usual horizontal axis.